Greetings! This lesson we're going to learn about how to use the spiral command to make three-dimensional spirals. The spiral command works by taking a two-dimensional object and extruding it into a three-dimensional spiral. To demonstrate the spiral command, I will be using it with multiple different sets of parameters so that you can see how to use it effectively and for a wide range of situations. I have already created a two-dimensional object here, which we are going to use to make the spiral. The object that we are starting with is called base shape, and it is a rectangle that I made using the box command, which is located 3 units from the y-axis and resting on the x-axis. Its far right side is 5 units from the y-axis. To use the spiral command, I have to specify 3 parameters. The first is the object which we want to extrude into the spiral. The second is the number of degrees that we want our spiral to turn around the axis. And the third is the per full turn spiral elevation, so the elevation that our spiral will go up the axis it's rotating around for every full turn it makes around that axis. So I'll make a spiral named my spiral using the all caps spiral command, using a first parameter of base shape, then 360 for one full 360 degree turn around the y-axis, and then a per full turn elevation of 4. Then I will put my spiral into the show command, and then I will run our program. Here is our spiral. There are a few things I'd like you to notice about it. Firstly, notice where the spiral is originating, right where our original rectangle base shape is located on the XY plane. Then notice that the face at the other end of the spiral is located at the other side of an XY plane after the spiral made a full 360 degree turn around the y-axis. Also notice that this other face is located 4 units up the y-axis above the original face. Additionally, you should take note that because the inside edge of our original rectangle base shape was 3 units away from the y-axis, the whole spiral has an inner radius of 3 units. Because its outside edge was 5 units away from the y-axis, the whole spiral's outer radius is 5 units. Next, what I'm going to show you is how partial rotations work with the spiral command. As you know, half of a full rotation is 180 degrees. We could just put in a 180 to the second parameter of the spiral command, but it is a better habit to put in a multiplier and multiply it by the number of degrees in a full rotation, which is 360. So let's multiply our 360 in the second parameter by 0.5 for a half rotation. Then let's run our program to see our half rotation spiral. Our spiral has now just turned 180 degrees around the y-axis. Notice that the end point is just 2 units above the starting point because the fact that half a rotation was performed and the full turn elevation is 4. Now let's try a double rotation, which is a 720 degree rotation. We know that it is a better practice to write 2 times 360 into the second parameter of the spiral to signify 2 full 360 degree rotations instead of just 720. So let's do that. At the same time, let's change our full turn elevation to 2 so you can see what effects that has on the spiral. And then we will run our program. Our spiral is now a spiral which turns around the axis 2 full times and has a per turn elevation of 2. This means that the total elevation of the 2 turns is 4. We can see that this is true by looking at the face at the end of our spiral here, which is 4 units above the x-axis. You now know how to change a spiral's number of turns as well as the per turn elevation of a spiral. Let me now show you one last example of me using a non-rectangular base shape to create our spiral with. I'm going to change the base shape here to a triangle made with the points 3, 0, 4, 1, and 5, 0. Then I'm going to change in the show command base shape so you can see just this shape and run the program. There is the triangle which we will be using to make a spiral, located again at 3 units from the y-axis. Now we can display the spiral that we're making with our new triangular base shape by putting my spiral back into the show command and running the program. Here's our new spiral. Notice that because the other two parameters in the spiral command were the same, it still makes 2 full rotations with a per full turn elevation of 2. So the 2 rotations still go to a height of 4. Our spiral is now made with a triangular shape instead of a rectangular shape. To summarize this lesson, remember that the spiral command works by extruding 2-dimensional objects on the XY plane into 3D spirals. It takes 3 parameters, the first for the shape to be made into a spiral, the second to give a degree measure for the number of turns for the spiral to make, and the third being the per turn elevation of the spiral. By adjusting the shape to be used, the shape of the spiral as well as the inner and outer radii of the spiral can be adjusted. By adjusting the second and third parameters, the number of turns that the spiral makes, as well as the elevation of each of these turns can be adjusted. Experiment with the spiral command and see what kinds of interesting shapes you can make.